Hey everybody, it's Brandon from STEM Tutor Club, and today we're going to talk about how to always get the first derivative test right without having to remember any complicated rules. So if you're interested, stay tuned. So first off, let's remind ourselves what the first derivative test even is. So the first derivative test states that if we find a critical point, then we can tell whether that critical point is a relative maximum or minimum with these rules. So basically, if the derivative, the first derivative, is greater than 0 to the left and less than 0 to the right, so positive slope to the left, negative slope to the right, then that means it's a relative max. If the first derivative is negative to the left and positive to the right of your point C, then it's a relative minimum. And then if it's the same sign, either positive and positive or negative and negative on the left and right of your point C, then it's neither. And this is a really good definition that comes from a website called Paul's Online Math Notes. If you just Google that, they have basically really good resources and really good definitions for things like this, which is why I like them. However, the downside of remembering a complicated rule like this is that it's easy to mix up. So how do you know that if it's like negative to the left and positive to the right? It's kind of tricky to remember whether that's a relative max or a relative min. So what I actually recommend is to not remember any of these rules and just draw it out. So instead of thinking about these cases, let's just draw it out. First off, for each of these points, we're trying to figure out if this is a relative max or min. And obviously we can tell just by looking at these whether they're a relative max or min the way I've drawn them. But remember, when you're doing these problems, you would do these numerically. It would only make sense after the fact, after you're looking at a graph, that you would be able to see something like this. So here, if we find that the first derivative is positive at a point slightly left of C and negative to a point slightly right of C, that's essentially rule number 1 here. You can see that that would mean it's a relative maximum. So if you have a positive slope and then a 0 slope at your critical point and then a negative slope, you can trace it out that actually must make a relative maximum. And then you have sort of the opposite. That's case 1. And then case 2 here, you sort of have the opposite case. So if we go slightly to the left, remember they're saying the first derivative is negative slightly to the left and it is positive slightly to the right. You can see negative, 0, positive. That literally traces out a relative minimum. And then for rule number 3 here, case 3 and 4 basically show rule number 3. If you have a positive slope to the right and a positive slope to the left, there actually is no relative max or min, because what's happening is we're going up, leveling off, and then we're going back up again. We're not turning around. So in other words, there is no relative max, even though this is still a critical point. So just to be clear, the tangent line here is still 0. It's even though the tangent line is 0, it's not a critical point because the slope doesn't change signs from positive to negative or vice versa. And then over here, you can see we have basically a similar situation just with negative slopes. So if there's no change, even if the tangent line at the critical point is 0, if there's no change in the sign of the slope from positive to negative or vice versa, it's not a relative max or min, which is what these two cases represent. So hopefully that makes sense. And what I would encourage you to do is, as you're thinking through and actually trying to apply the first derivative test during any problems that you're working on, actually just draw it out and visualize it. Just let me know if you have any questions, and I'll catch you next time. See you.